Assalamualaikum warahmatullahi wabarakatuh. Greetings, Mr. Dai. My name is Laksana Pratama Lingga. Today, I'm with my partner, Danendra here, and we are going to discuss about examples of numerical method and review about the lecture. Next. So as we know, before we discuss about these things, obviously we need to use the E5 on its method, to solve these kind of problems. First of all, we have to be in a conscious condition, which is we always do with our heart. Our heart is to decode, my brain is to decode. So I think that's what conscious thinking is, because obviously we're doing this because of God, not because of anything. So uh that's what conscious thinking is for us, into before we continue, obviously we need to have conscious thinking. And then after that is intentions. So intentions means how interested are we in some kind of problems. And obviously we need to have high intentions in order to give a maximum effort and high results and high output, because obviously when it comes to high intentions, you do have an expectation, and expectation is very high, so you need to fulfill that expectation by doing maximum efforts into it. So that's what Mr. Day told us to do, so we're doing that in this moment. So yeah, that's intentions for us.
I think
uh
I want to continue.
yeah.
Okay, so we will go to the initial thinking part. Of course, initial thinking is the part where we will use it to uh, detail the problems, divide the problems into smaller details so we can understand the problems correctly. And by dividing details, we can know the problems, and it's easier for us to know like which problem is like the root cause of the problems. It's like that. And we go to idealization. The idealization is the part to find the, usually if try to solve an equation problems, we usually find the formula that is relevant to the problem. So in this idealization part, we do that. And also we also use modeling on this part. I think that's it. And then the last thing is instruction. Is This step is the solution step, which guide us step by step to acquire the solution by using all of the framework and compile it into one, and then we will get the solution.
Okay, moving on to intentions. So we always pray to God before we do these conversations and discussions about numerical methods. So obviously I'm going to pray first, to pray to get easiness into discussing problems with my partner. So the pray is Allahumma la sahla illa ma ja'altahu sahlan wa anta taj'alu hazna iza syi'ta sahla. Ya
Amin ya
Allah.
rabbal alamin ya Allah.
Amin, amin, amin. So the challenge is numerical method question. So next. So what is initial thinking about the problem? So the initial thinking of the problem is, in numerical method situation, is to improve knowledge and can determine what is harmonic oscillations, or as simple as Maclaurin's and Taylor's. So we aim to have a good analysis on certain cases, which is includes harmonic movements, and try to understand how to solve these problems step by step using the E5 methods. We solve these problems pure because of God, for the sake of God, as He is the Creator who made us and facilitate us to live in planet Earth. So always remembers God in every single activities that you are going to do. Okay, this is the idealization case number one, which is damped harmonic oscillations. As you know, the formula is x equals to a cos omega t plus theta, which means it's undamped oscillation. And then uh, damped force means minus b times v, which is b is time constant, and there is a Newton law in this damped oscillation thing, which is called mean kx minus bv equals to ma. And after that, there are our differential, which is m d quadrat x divided by dt quadrat. So 2 times of differential with time, and then plus b dx per dt differential to time 2, and last one is plus kx equals to 0. This is the graphics. And next one. Okay, so under them means b quadrat is less than 4 times m times k. So you can see this, it's starting to, from very, very big gaps into small gaps into stable ones. When it comes to overdamped or critical damp, you can see that the graphic is, moving forward towards downwards, so b quadrat equals 4 times m times k, and after they went downwards, they became stable. And when it comes to overdamped, you can see there are not much of a difference between overdamped and critically damped, but overdamped is defined by b quadrat is more than 4 times m times k. You can see that the graphic is, it's not that much of a difference between critically damped and overdamped. Next one. So this is the example, uh there are springs with constanta of 250 newtons per meter connected to things with a mass of 2.5 kilograms on a slippery surface. And when it comes to times equals to 0 seconds, this thing is stood by 4 centimeters in x positive and has a velocity of 0.4 meter per second to x negative. The question is, how you determine the position, the thing in, cosinus function. So yeah, next. This is the formulas. This is idealization of the E5. Obviously, when it comes to initial thinking or um, conscious thinking, we are in a conscious thinking, so we can analyze the problem itself. We need to determine which position is thing going to be. So after that, we can analyze. So the first one is the idealization is we have to determine the spring oscillation and then the speed of the thing of the benda, and then you divide by 1, and then after that you can get the a, which is 4 times root or 2. X equals to 4 root 2 cos 10t plus phi divided by 4 centimeter. Next one.
Okay, Alan, I will take it from here and I will discuss about case 2. And case 2 is about simple problems about Maclaurin. So we will go to the idealization part first. So the question is, find Maclaurin for fx equal 2 plus x divided by 1 minus x. So first, we will find the formula that is relevant to this question. So down here, we have the formula for every f function that is differential to point C. The function can be expanded. So function x equal function C plus function turunan 1 divided by 1 factorization and times x minus c, and so on and so on. So the turunan keep on going down and the factorization keep on going up, and then the x minus c pangkat keeps on going up too. So this is like a continuous continuous formula, and then this is the formula where you can check for x equals 0, and then we have 2 right here, and then f being turunin sekali, and then check x for 0, and then it could equals 3, and then for the second derivative is 6, for the third derivative is 18, and for the fourth derivative is 72. Oh, my bad, sorry. For the fifth derivative, it is 72. So we do a calculation for derivative to make us easier to solve the Maclaurin problems. So here there is the Maclaurin problems using the formula before, right? So it's the same, like 1 vectorial, and you can see 1 vectorial, 2 vectorial, yeah, and x minus c is 0, so like only x, because x minus c, x minus 0 is x, and then so on and so on and so on. So the answer is down here, 2 plus 2x plus 3x tambah 3x pangkat 3 tambah 3x pangkat 4, so on and so on. So I think that's all for equation problems that we're trying to solve today on numerical methods, and then we will continue to review about the lecture that we have done with Padai on numerical methods. Lang, do you want to start first, or?
Um, I think after learning with Mr. Dai, I got new perspective of learning, because Mr. Dai always told us to change our mindset about learning. You learn because you want to, not because you need to. Because when you learn because you need to, you will forget the seconds you stop learning. But if you learn because you want to, obviously you will remember as long as you can, So I think that's the added value, and that's memorable for me from Mr. Dai. I think that's uh one of the things that I learned so much about Mr. Dai, and also he always taught us to remember that. Well, you can continue.
I think I'm very much agree with Lang, because Mr. Dai told us to always learning, and it reminds me one of Donald T. Phillips quotes, like the best leaders never stop learning. So basically, Mr. Dai teach us how to be a leader for the future, because he told us to always learn, and always learn for ourselves, not for the teacher or for someone else. And I kind of want to explain about the DeFi concept along. So, like yesterday we do a quiz about to compare about DeFi and the mic, and I think there is a little bit difference. Like DeFi have intentions part, where this part I really like, because intentions part make us, you know like intense, it calms our soul. So it's like we give ourselves to God, so God can help us to do the task. And I think it's very much helped me through this, like solving problem things. What do you think, Lan?
Yeah, I agree with you. Obviously, when it comes to, give ourselves to God, it's just the way you think, So after you gave yourself to God, obviously you're hoping for something that is better than what you think. So I think from that perspective is a very good perspective to to take.
Okay. I think Alang pretty much agree with me. I think there's one more topic that I want to talk about. So I remember that Padai have told us about uh, hardware and I think brainware, if I were to remember. And I think Alang is disconnected. So I will explain a little bit about hardware and brainware. So brainware is oh yeah, he's there. Okay, so do you want to explain first about brainware and hardware? Or
Obviously, brainware and hardware, these two are the difference between humans and robots. Robots, they didn't have the, hardware where we humans have. And that's the most important thing. Sometimes hardware could be the key decision, because robots, they work by instructions, not by their hearts. So that's our benefit as a human, to have heart, and to decide what's the best for us, because robots, they don't know what's the best for them, they just doing what they're given to. I think that's what matters for us humans. What about
yeah,
you?
I very much agree with Alang too, because if we don't use our brainware and hardware, so what are our differences to robots? So we just, it just feel empty. If we don't use brainware, it's like we don't have a brain, and if we don't use hardware, it's like we don't have a soul. So we don't like thankful to God, and so on and so on. I think that's it for our discussion today. Do you want to add something, Alang?
Uh, so I think that's all from us, Mr. Dai. Thank you for being our teacher, our lecturer in this half semester. It was a memorable journey, to learn from you, to learn something that, other lecturer hasn't teach us, about intentions, about gods, about everything. So we appreciate what you did, Mr. Dai. So yeah, I think that's from me. What about you?
Yeah, I think that's pretty much it. My impression is same like Alang. So thank you, Mr. Dai. Sorry for if we have done wrong things when we were in class. And then that's it. Uh, Assalamualaikum warahmatullahi wabarakatuh.
Okay. Thank you, Mr. Dai.
Thank you, thank you, thank you.